Welcome to another edition of our class on FBA 120. That's the course code and the course title, Calculus for Business Students 1. So far in this class, we have looked at polynomial. What is polynomial? The degree of polynomial, the coefficient of polynomial. And we have also looked at how do we add polynomials together. And I did mention that the reason for all this is to ensure that we understand the concept of polynomial before we start differentiating polynomial. After that, we now look at the concept of calculus as differentiation as rate of change. That is, differentiation deals with how a variable changes with respect to another variable. That's the basic thing that differentiation came to address. To business, we have explained that majorly we'll be looking at marginal concepts, marginal revenue, marginal cost, marginal profit, and optimization generally. How do we minimize costs and how do we maximize costs? And we were introduced to how to carry out differentiation as far as polynomial is concerned. You recall that we said that suppose we have y as a function of x. Let me just take a simple example, 15x raised to the power 7, for instance. We said that our dy dx is power multiplied by coefficient, then x raised to the power minus 1. Or you can switch this. You can write as coefficient multiplied by power. Since it is a multiplication, it is commutative, so we are going to obtain the same results. That is how far we have gone. So today, we now start calculus in full. How do we differentiate function? What are the basic rules that we need to follow? What are the techniques of differentiation that we need to know? Once again, you are welcome to another edition of this class, FBA 120, Calculus for Business Students. As a way of revision, everybody kindly attempt this question. Find the derivative of Find the derivative of y equals ax raised to the power 4 plus bx raised to the power 3 plus cs squared plus dx plus k. Everybody kindly attempt this in less than 1 minute. Okay. Esther Gaji, kindly unmute yourself, please.
Good evening, sir.
Good evening.
Yes. So the answer for that question is 4ax cubed.
First of all, before you state the answer, what is the notation?
Sir?
What is the notation?
I don't understand.
Okay, let me help you. The notation, dy dx.
Yes. Okay.
Pause. Okay, now go ahead.
Okay. 4ax cubed
4ax cubed
plus
plus
square
3
3b
x
x
squared.
square
Okay.
plus
Yes.
2cx
2cx.
plus d plus 0.
Plus 0. Okay. So you are saying that this is your final result. I
Yes, sir.
disagree with you on this.
Okay, sir.
I disagree with you. You will see the result very soon. So
Okay,
who
sir.
else want to try? Who else would like to try? Or any Yoniola, kindly unmute yourself, please.
Yes, sir.
Yes, what's your result?
4ax cubed
Okay,
plus 3bx squared
okay,
plus 2cx
okay.
plus d.
Uh-huh.
That's all, sir.
That's all. So
Yes, sir.
the same result with Gajara
That
and Esther. Okay. I will tell you very soon whether the result is correct or not. Someone said +1. Calvin Bandi, kindly unmute yourself, please.
Yes, sir. Good evening, sir.
Good evening. How are you?
All right, very well.
Oh, sorry. Unmute yourself again, please.
Constant is 0.
Okay.
Derivative of constant is 0.
Sir, can you hear me now?
Yes, very well.
All right. 4ax cubed
Mm-hmm.
plus 3bx squared
Yes,
plus 2cx
yes.
plus dx plus 0.
Plus dx.
Yes.
Okay, divide the x. 4ax cubed plus 3bx squared plus 2cx plus dx. How do you obtain your dx?
I think since the x does not have any power, I
Are you
assume it's
sure?
1.
Are you sure that
Yeah.
there is
I
no
assume
power?
it's 1. The
The
power
power
is
is
1. Raised to power 1.
Okay,
Raised
the
to power
power
1, which is 1 times d is just d. The
okay.
x still remains.
Are you
The
sure?
x still remains. I
Are you
believe so,
sure?
sir.
Are
I
you
believe so,
sure?
sir. Yes, sir.
Look at the formula. Power times coefficient x raised to power minus 1. That's your formula. So if you subtract 1 from the power you have there, the answer will be D. In order not to waste our time, the first two speakers got the answer perfectly correct. Hamed from the chat room got the answer perfectly correct. Gideon Nwosu from the chat room also got the answer perfectly correct. So thank you so much. The board is not clear. No, that's not, I'm not too sure. 3 people complain about the board. Okay, I will make my handwriting for you. So that is that. So today, we will now go to the general rule. Differentiation now. Differentiation. General rule. If y equals ax raised to power n, the y dx, what is the answer? So that this is where I should have started from, but I decided not to start from there so that I will not bother you with too many mathematical terminologies. So what is the result? What is the result? Samuel Athanasius. Kindly unmute yourself. Samuel, what is the answer to this question?
Okay, my answer is a n x
A and
raised to power n minus 1.
n minus 1. So this is the general rule for differentiation of a polynomial. We call it power rule. We call this one power rule. So I'll work more on power rule today, and possibly we move to another area. Now, notations. Equivalent to dy dx are the following. Suppose I put this d dx into ax n. I will only write the answer. There is no need of writing the y dx again. The answer will just be a n x n minus 1. So this is notation 1. Another notation. I have f of x equals ax raised to power n. The derivative of this, the derivative of f, you can write it in two forms. Either we write it as the f dx, but I don't want this one because that is equivalent to this, to what I have here. So I want to use another notation entirely. And what is that notation? The notation now is f prime of x. Anytime you see f prime, it means differentiate once. F prime of x is a n x is power n minus 1. Chisoba Joy, kindly unmute yourself.
Good evening, sir.
Good evening, how are you?
I'm fine, sir. Me, I don't understand though.
Which one do you not understand?
This one, dy dx equals to n x, then n minus 1. How do we arrive to that?
Just hold on.
Okay.
Don't go yet. I have y equals to 4x raised to power 3. What is your answer?
4x 3 minus 1.
4.
Y equals to.
What?
What was your question, sir?
Y equals to 4x raised to power 3. Let me rewrite it. Look up y equals 4x raised to power 3. Differentiate this using what I told you in our previous class.
So it's supposed to be 4x 3 minus 1.
Are you sure? Or is it 4 times 3?
No.
Are you sure?
Yes.
Are you with your notes? I can see that you're on transit. Are you with your notes?
Yes, sir.
Okay, can you go back to your notes? Read out the formula.
Power times circumference.
Power times coefficient.
Oh,
Power
sorry.
times coefficient.
Times power minus 1.
Okay, x raised to power
Minus 1.
minus 1, Abi.
Yes, sir.
Okay. Now here, what is the power?
3.
3 times what is the coefficients?
X.
The coefficient here, what's the coefficient here?
4.
4. X raised to power 3 minus 1.
Minus 1.
Now let's start from here. What's your power here? What's the power in this?
N.
N. What's the coefficient?
A.
A. X raised to power what?
N minus 1.
N minus 1. Thank you. That's how we arrive at this.
A, but in this one, now A is coming before N now.
Yes, because coefficient can come before power. I told you that
Okay.
you can have coefficients times power. Our coefficient is 4 times 3. 4 times 3 and 3 times 4. Do we have different answers?
No, sir.
No. So NA and AN are the same.
Okay.
They
Thank
are
you.
multiplying each other. Thank you so much.
Yes, sir.
Yeah. There is something I love about Joy. He was blunt. That's her. Don't go too far. I do not understand this. Afolabi, Rashida, kindly unmute yourself.
Good evening, sir.
Good evening. How are you?
Very well, thank you, sir. And you, sir?
I'm fine.
First of all, my what I was supposed to ask has been answered. I wanted to ask that can we multiply coefficient times power?
Yes.
So yes. And second, I want to ask about particular about this dy dx. That's what I'm particular about. Like, what do they do? Like, what's the essence of the dy dx, sir?
Okay. Thank you so much. Thank you so much.
Yes, sir.
The essence of the y dx is notation. That is the notation we use for calculus. Sorry, for differentiation. So we have
Oh.
different notation. Just hold on. I have rubbed off something here, which is a n x n minus 1. Let me take you back to secondary school. Are you there, Rashida?
Yes, sir, I'm there, sir.
Now, if I write this, what does it mean?
Sir, I don't know, because in my secondary school, I don't know
Don't
math.
worry, don't worry. You will know
So
now.
it's you that made me love mathematics, sir, and I'm getting
Don't worry. P is principal times rate times time. Principal times rate times time. What does this
Okay.
one mean? This one means interest. This is just notation. We use I
yes.
to represent interest.
Okay, sir.
Another thing can be used, not necessarily I, but generally, in order not to confuse students, we make I to represent simple interest. Same
Okay.
apply in our statistics. If I write X bar without telling us the meaning, everybody knows that this simply means me. So the bar there is just differentiated from ordinary X.
Thanks.
Yes.
Okay.
So this is notation. So for calculus, dy dx, y prime, f prime, d dx are different notations that we use to represent differentiation.
Okay, sir. Okay, sir.
Yes.
Thank you very much, sir.
Let me quickly go back to some of the whole thing is looking strange to me. Can someone help, please? John Fash, kindly raise your hand, please. John Fash. John Fash, please raise your hand. John Fash. John Fash, I am waiting for you. Olofugboaro Peter, I will answer your question. I have seen your question. Sir, is it compulsory? Is it not compulsory to add y? Add the notation like the y dx? I will answer that question soon. John Fash, kindly unmute yourself. I want to react to your statement here from the. So let me know what the problem is. John
All right,
Fash,
thank you. Good evening, sir. Thank you very much for your time.
you are welcome.
So I'm actually joining the class for the very first time. And
That is where issue lies. Because we
So I
have
don't-
had 2 previous classes. Then just yesterday, I repeated those 2 classes for those that have not joined earlier, so that today class, all of us will be on the same page. And you did not join yesterday again. So it will be very difficult for me to actually move back. So maybe we discuss after the class on the way forward.
All right, sir.
Yeah, but just keep following the classroom. Florence, kindly unmute yourself.
Good evening, sir.
Good evening.
I wanted to ask if the F prime is the third notation.
Yes, F prime is on notation.
Okay,
F
thank
prime is notation for calculus, notation. I hope you are following. Look at the following notation. dy dx is a notation. D dx is a notation. F prime is a notation. Y prime is a notation. All these notations simply means derivative. It now depends on how the question is structured. Take, for instance, let me pick a single question that I will use all the 4 notations. If I have given you y equals to 5sk, the notation that follows is dy dx equals 15x raised to the power 2. If I've written it as f of x equals to 5s cubed, I will write the answer as f prime 15x squared. You observe that the answer still remains the same. I have not changed the answer. The only thing that changes is the notation. Why this one is written as dy dx, I have written this one as f prime. Same question, I can write as d dx of 5x power 3. The answer will just be 15x squared. You see, I have not changed the question. I have not changed the answer. Oh, sorry. D dx of 5s cubed, 15x squared. What is changing is just the notation. Let me use the last one. I have y equals 5s cubed. I don't want to write this one. I said, don't let me write this. I can write that y prime equal 15x squared. So these are the basic notation that we use. It now depends on how the question is being asked. Oh, Johnson Fash, you are a direct entry student. Sorry about that. So y equals 5s cubed. The notation that follows is dy dx, which represents change in variable y with respect to change in variable x equals 15s squared. This one, f of x equals 5s cubed. The notation f prime simply means the change in f with respect to x is this. This one means d dx, that is differentiate what you have inside the bracket with respect to x. We have 15s squared. And the last notation also follows the same pattern. So that is that. That is that. So that's our basic notation. So everybody in the class, let me now take examples. We are still using our formula. Find the derivative of the following function. A 5x squared. B, 1 divided by x. C, square root of x. D, cube root of x squared. C, let me say I have 2 divided by x raised to power 4. Let us take this one after the other. I will be using different notation so that you will be familiar with all our notations. Solution. A, if I put y equals 5x squared, what will be the results? What will be the results? Yes. I want the result in full. I don't just want 10x. There must be something I must write that will indicate that I have differentiated. Yes, from the house, the chat room, all of you get the answer. Thank you so much, Richmond. Richmond Chika. Thank you so much. I really love what you have written. You have written it. You have decided to use y prime equals 10x. Correct. Correct. That is notation you have selected. Perfectly correct. If I don't want to use y prime, what other notation can I use? Yes, dy dx. Olofugbo Peter. Thank you so much. I can write it as dy dx equal 10x. All these are just notation. The result is clear. The result is 10x. So B, I have, let me write it as f of x instead of y equals 1 divided by x. What is the answer to this? Do not forget the formula is power multiplied by coefficient or coefficient multiplied by power, then x raised to power the power minus 1. Esther, kindly unmute yourself, please.
Good evening, sir.
Good evening, yeah.
I just want to try.
Try, please.
Okay. Okay, f prime x is
F prime
equals
of x.
f prime of x is equals to okay, that 1 over x, we're going to change it to x raised to power minus 1 first.
Almighty God will bless you.
Amen.
That is the first thing I want to hear. Almighty God will bless you. In fact, oh, some people, okay. Let me start the mark. 1 mark for that. Because
Thank you,
if you
sir.
don't write it that way, you are not going to get the answer.
Yes, sir.
Thank you. Okay, go ahead, please. So he said we need to write this one first as x raised to power minus 1. That is when we can see the power and we can have the coefficient. Go ahead, please.
So then it will now be minus x raised to power minus 2.
Minus x raised to power minus 2. Perfectly correct. Clap for yourself. Let me hear your clapping. Thank you so much. Thank you so much. So this is the answer. And if you don't want to leave the answer like this, you can write now as minus 1 divided by x squared. Law of indices.
Yes.
Law of indices. Thank you for that brilliant idea. I really appreciate. Thank you so much. Afolabi Rashida, kindly unmute yourself, please.
Yes, sir. Please, I don't understand.
You do not understand.
I do not.
I will make you to understand. Now, I have 1 divided by x. And
Okay.
what we have told ourselves is that it must be written in terms of a x raised to power n. Not our x must not be at the base, must not be at denominator.
Okay,
It
sir.
must be in this form. I hope you can see past this part of the board.
Yeah, I can see, sir.
Now, however, 1 divided by x, is it in this form?
No, sir.
No. So the first step before we go for differentiation is to write it in this form. Then
Sir, excuse me, sir. No, excuse me, sir. I'm
Yes.
not talking about this particular solution, this number solution. Like I'm talking starting from the first one, like y raised to power 1, then
No,
10x.
not y raised to power
not-
1. This is y prime.
Okay, y prime.
Yes.
I do not understand, sir.
Y prime simply means the y dx. It's just notation.
Okay, sir.
So then do you
Sir,
understand how I get 10x?
yes, because I I think the one we did last, I think is in multiplication. You
Yes.
said power times coefficient,
That is
then raised
what- yes, that is what we are doing. I have not changed anything. That's what we are doing. I am just trying to introduce you to notation. That when you write your results, how will I know that what you have done is calculus? How will I know that you have differentiated?
Okay.
I hope you are following.
Yes, sir.
What makes me to know that you have differentiated is the appearance of this.
Okay,
The
sir.
appearance of this. The
Okay, sir.
appearance of this. Then I know that you have differentiated.
Okay, sir. Okay, sir. Okay, sir. Thank you,
So,
sir.
yeah.
I
Thank you.
guess I understand now, sir.
You're
Thank you.
welcome. Madam Florence, kindly raise your hand. Florence Osemudrame. Florence. Thank you. Let me listen to you, please. In the chat, you complain. So let me take your complaint, please.
Good evening, sir.
Good evening.
I understand the notation, but I don't understand the solutions of the question.
A
Like
or
the one,
B?
the questions you wrote.
These are the questions.
Yes, I don't understand the A and the B that has been solved.
Thank you so much.
Thank you, sir.
Don't go yet. Has she gone? No. Unmute yourself again, please. Yes, thank you.
Okay.
Now, sometimes this is the way the question will come. Sometimes the question will be clear. Y equals 5s squared. Differentiates. Florence, were you in our former 2 classes, the previous 2 classes?
I wasn't, but I listened to the recorded class.
Thank you. In the recorded class, we said it is power multiplied by what? Coefficient. Now, the power, what's the power?
2.
Multiplied by 5.
5.
What's the answer?
10.
10. Subtract 1 from here. What is the result?
Oh, I can't see.
Subtract power from that. Subtract 1 from the power. What's the answer?
1.
1. So this is 1. That's how we get our result.
Oh, okay.
But what makes us to know that we have performed differentiation is this notation or this notation. That's what makes us to realize that we have indeed performed differentiation. We have differentiated the function. Is that a
Thank you,
difference?
Yes, sir.
Now, before you go, Florence, take this. Suppose I have y equals 7x raised to the power 4. So differentiate that. What is your result?
Y prime.
Y prime, thank you. If you don't want to use y prime, what will you use?
dy over dx.
Thank you. These are what I just want to be hearing from you. Y prime, if I don't want to use it, I use the y dx. What's that your results?
28x.
28x, ordinary x,
X cube.
s cube. Thank you.
Okay.
How did you get your 28?
Power times coefficient.
Power times coefficient. That's one. How did you not get your 3?
Power minus 1.
So that's all. That's what you're doing.
Wow,
I
thank you
have
so
not
much.
introduced anything today other than notation. What notation do we use to represent it? So that anybody you are presenting it to will know that you have differentiated.
Thank you, sir.
I'm still using what we did in the previous 2 classes. We have not introduced any other thing. Thank you.
Thank you.
Hola, ma, my sister. How are you? Kindly unmute yourself. Hola, ma.
Good evening, sir.
Good evening.
Sir, please, I don't understand how you got this, the answer to this B. I understand how we changed this to x raised to power minus 1, but I don't understand how we got x raised to power minus 2.
Thank you. Hola, ma. You will help me. As usual, I will act like an African man who uses question to answer question. Hola, ma, you said you understand how we obtain this. Am I right?
Yes.
Hola, ma, what is the power?
Minus 1.
Minus 1. What is the coefficient?
0.
The coefficient
There's
here?
no coefficient. No coefficient. Let's say
If
it's
there's no
1.
coefficient, what do we put there?
1.
1. X raised to power minus 1. That's our original power. Then what will you do to this power?
Okay, minus 1.
Minus 1.
I get it now. Thank
Now
you, sir.
clap for me, clap for me, clap for me. So that is just that's what we have not changed anything. We have not changed anything at all. Just ensure that you sit down, you are patient enough at this stage. Look at the formula: power multiplied by coefficient, or coefficient multiplied by power. Then from the power we subtract 1, and that result will come up. Let me quickly read messages. Okay, thank you. Nneka, Omotoyosi. Kindly unmute yourself, Nneka.
Good evening, sir.
Good evening.
Sir, my question is the power, the 1 minus 1. 1 minus 1. I don't.
This one?
Yes, sir.
Minus 1 minus 1. Minus
Yes.
minus 1 minus 1 will give us minus 2.
Sir, I don't know how you got the minus 1. The only minus 1 I can see is when you convert the 1 over x into
I hope this is not your first class.
No, sir, this is not my first class.
Okay, can you go back to your notes? Open your notes.
All right, sir.
Then go to the formula. Power multiplied by coefficient.
Power multiplied by. Okay, yes, I'm there.
You are there. Okay, let's
yes,
start.
sir.
What is our coefficient?
X power minus 1.
What is our coefficient? Just hold on. What is our coefficient?
In this question?
Yes.
X.
The number that's supposed to be here. What's that number?
No, number 1.
1. Times, what's our power?
Minus 1.
Minus 1. Now, go to the formula x. Then what do we have here in the formula?
Power minus 1.
What's our power?
1. Minus 1. Minus 1.
Minus 1. Then minus, what are we
1. Okay,
1.
okay, sir. Okay, sir. That's 2. Yes, sir. Minus times minus is plus. Yes, I
No,
understand. Thank you
no,
very much.
no. Here, this is a deficit of 1, another deficit of 1. Then what do we have?
Minus 2.
Minus 2. Thank you. Where you're going
Thank you,
to
sir.
multiply is 1 minus 1. Do you see the difference?
Okay. Yes, sir. Yes, I can.
Okay, thank you. So let me
Thank you very much.
continue so that we move on. We move on with the class. Thank you all for your contribution. They are appreciated. Now, let me take, okay, we have answered B part of the question. Let's take the C part of the question. C, let me use, use Y equal square root of X. How do we differentiate this? What are we going to do? Yes, some people have made effort here. Okay. Before I answer that question, Abu Godwin, kindly raise your hand, please. Abu Godwin. Let me react to your message. Kindly unmute yourself, Abu.
Hello, sir.
Good evening. How are you?
Good evening, sir. Fine, sir.
Good evening. Good evening. Have I answered your question or you still don't get it?
So,
Network.
That's yes, sir. Yes. I understand it now.
You understand it now. Thank you. Yes, a lot of has been written here, and I love this. So the first step, we are not differentiating first. We must ensure that square root of X is written in this form. That is the only way we cannot differentiate. How do we write it? I can write this one as Y equals X raised to power half. So it is now in this form. Where is that form? It is now in this form. Then what next? What are we going to do from here? No, Esther, not you. Another person. I'll be forced to call name Olama. Okay, let me take Olama. Olama, over to you, please.
Okay. We'll say 1/2 times 1.
1/2. You have not.
Sorry, Y prime. Sorry,
Y prime. So that's what I want to be hearing. Talk calculus now. Talk differentiation. So okay. That's what I want to be hearing. Y prime, dy dx. So I want to be hearing all those. So it's not be 1/2 times 1.
Yes, sir.
How did you get your half?
That's the power. Power times coefficient. Coefficient.
Let's proceed.
X raised to power 1/2 minus 1.
1/2 minus 1. So y prime now equals half times
1/2x.
1/2
X raised to power minus 1/2.
X raised to power minus
1/2.
That is the answer. If you don't want to write the answer in that way, you still want to go further, you will now apply law of indices. In the law of indices, y prime now becomes 1/2 times 1/x raised to power half. 1 times 1 will give us 1. Then 2 times x raised to power half will give us 2x raised to power half. You can as well leave your answer this way. You can see, I said we can leave our answer this way. If we like, we can leave it this way. And if we like, we can move a step further. Convert this one back to root. 1 divided by 2 square root of x. So 3 ways through which the answer can be left. Oye Blessing, kindly unmute yourself.
Good afternoon. Good evening, sir. Sorry.
Good evening. How are you?
I'm fine, thank you. So, this C, I did not understand how you get 1/2 because I thought that this root x is supposed to be square. It's supposed to. So I don't know how I don't understand why it's.
Thank you very much. There's a difference between square root and square. They are never the same. There is a serious difference between the two. So there is a big difference between square root and square. They are not the same. Take for instance, if I have 2 squared, here, what is the answer? Here has run again. Here, Blessing, kindly raise your hand again, please. Here, Blessing, kindly raise your hand. Blessing, I'm waiting for you, please. Blessing, you are the one that asked the question. Please, I need your attention. Here, Blessing, kindly unmute yourself, please.
Okay, sorry, it's my network.
Network. Okay, no problem. Now, what is 2 raised to the power 2? Network. 2 raised to the power 2 give us 4. Then if you now have square root of 4, what does it give us? What is the result of square root of 4?
Square root of 4.
Square root of 4, what's the answer?
Oh, square root of 4, that is 2.
That is 2. So are they the same? Square root and square are not the same. Now, according to the law of indices, the law of indices states categorically that when you have
yes,
NA, the answer is
no.
A1/n. That's law of indices. So that's what law of indices states. Now, in the case of the square root, in the case of square roots, it is always believed that the number we have here is 2. So that the answer will now become A1/2. And that's the reason why square root of x here becomes x raised to the power 1/2. So we just apply law of indices at this point. Indices. Maybe I should write it that way. So we apply the law of indices at this point. Then it is this point that we differentiate. Any question? Any question? If there's no question, let me move on. Someone asked, okay, Damilola, I'm coming. Someone asked that, how did 2x raised to power half becomes 1 over 2 square root of x? It is still the same rule. Rule of indices say that 1 divided by n equals the denominator will come here. While what you have here as your base will go into the square roots. That is the law I have applied. So for x raised to power half, it's going to be square root of denominator, which is 2, supposed to be here. And x will go into the roots. However, if it is 2, we don't normally write it. So that's why you are not seeing it. Suppose we have it as 3, I would have put it there. So I hope I have answered your question. I think the person that asked the question is Fumi, if I am not wrong. If you are the one that asked that question, kindly, okay, yes, thank you so much. Thank you so much. Now, let us move a step further. Let us move a step further. D, let me stick to Y for question 1. I have it as cube root of x raised to power 2. How do we differentiate this? Okay, Sonny Adeyemi, I will take note of that. You said I should help the slow learner, but let me ask this question. I hope I am not too fast in today's class. Please, if I'm very fast, let me know. Just type fast. If I'm very fast in today's class, okay. Some said that I'm fast, some said I'm not fast. But there's no problem. I will try to balance it because I don't want to move very fast. Once you understand this basic, oh God, others will just be easy. Will just be easy. So now, how do we handle this? How do we? Don't forget that you must write it as a x n raised by n. This must be the way we must write it. Is it in that form? The answer is no. How can we write it in that form? Esther, no, I will not call Esther. Now that people are not ready to, sorry, I need to reply one message here. Yes. Damilola, kindly raise your hand, please. Sorry. Good evening. How are you?
Fine, sir.
Yes.
So I want to attempt the question.
Attempt it, please.
So we have y prime equal to x squared times 1/3.
X squared times 1/3. Where did you get your 1/3?
From the cube root, sir.
From the cube root. Okay. Let's first of all write it in this form so that you get the answer right. Write it in this form. How will this one look like?
Okay, so it will be it will be 2 times 1/3.
Times 1/3. You are
Yes, sir.
you are perfectly correct at that point. Don't go away.
Okay, sir.
Do you now agree? Let me help you here that I can write as 2 over.
Good evening, sir.
Yes, sir.
So you agree that we can write as 2/3.
Yes, sir.
Now apply your rule now. Why prime? What will be the next step?
2/3
2/3
x.
x
2/3
2/3
minus 1.
minus 1. Thank you so much. Thank you so much. You got the answer right at that point. So we just need to simplify now. So please, I want to beg you, Damilola.
Yes, sir.
What you try to do at initial stage.
Okay, sir.
For us to tell me that you are now a professional. No, you are still an amateur. Work in an amateur way. You always get the answer. If you behave like a professional, you will make mistake.
Okay, sir.
So
yes,
you know exactly what to do, but because you want to quickly get the answer, you make mistake at initial stage. Please always take your time.
All right, sir.
Yes, at this stage, I don't expect anybody to quickly get the answer. Take your time. By the time you do it 2 or 3 more times, you are accustomed with it, then you can tell me the answer directly. Thank you so much, Damilola.
Thank you, sir.
Yeah, you're welcome. Kolawole Ridwan.
Hello, sir.
Hello.
Good evening, sir.
Good evening. How are you?
Fine, sir. Sir, please, this last part, I didn't get it. My network was so bad, so I didn't understand the
So that means
explanation.
that you got to the class very late.
No, I mean this last part, this number D, just this D only.
Just this D only. That's not
Yes, yes.
Hold on. Stay online. Stay online. Stay online. Now, law of indices. How can we write cube root of x squared from the law of indices? Kolawole? Kolawole is gone. Kolawole, kindly unmute yourself again, please.
I'm with you, sir.
Yes. I want to write this cube root of x squared in terms of
sir.
ax raised to power n. I need law of indices. How can I write this? From law of indices.
It will be x raised to power 2.
Yes.
Over yes equals. I didn't understand, sir. I didn't understand.
Okay. The law of indices. Let me help you. Law of indices says that if I have n a like this, it is a 1 over what I have outside, which is n. So in this representation, what is my a in this representation? Kolawole, don't mute yourself. Unmute, please. Kolawole, kindly unmute, please.
Sir.
Yes. In this representation, what's our a? Look at this. Look at this. What is a?
X.
Ordinary x.
X raised to power 2.
X raised to power 2. What's our n?
3.
3. So this is now 1 over 3. Did you see it? That
Yes.
I have written this one in this form now. That is the first step before you differentiate. At that stage, we have not differentiated at all. We just want to ensure that we write it in this form so that there will be power on top of our x. Now, having done that, I can now multiply 2 times 1.
2.
So that is 2/3. Now I have written it in this form. I have written it
Okay.
in this form. So how do we now differentiate? Our dy dx is 2/3, which is our power, multiplied by the coefficient, which is 1, then x raised to the power minus 1. That is how we obtain this. And I have not gotten to the final result. So any question? Okay, Kolawole is gone. Joy, kindly unmute yourself. Joy Chizoba, kindly unmute yourself, please.
Good evening, sir.
Good evening, Joy.
I'm sorry, but sir, this number D and C, I really do not understand. The only thing I understand from all this one we have been doing so far is only that number A.
You understand A, am I right?
Very well, yes. But you see this.
Hold on, no, Madam Joy, hold on. Hold on now. Did you understand A?
Yes.
Do you understand B?
Not very well, oh.
Not very well. Okay. I can see so many comments here. Okay, let me write that B here. I guess where problem lies is our indices. That is where problem lies with the remaining part of the question. We have forgotten the law of indices. So I will help you. The law that I'm using basically is this law, that a raised to power minus n is 1 divided by a raised to power n. So this is a general law in indices, which now says that a raised to power minus 1 is 1/a. If the question comes in this form, you change it to this form. Now, if you look at B, what I have was 1/x. Now change it. What will it be, Joy?
X minus 1.
X raised by what?
Minus 1.
Thank you. Thank you. X raised to the power minus 1. We write it this way just to ensure that it is in this form. Please, everything we are doing in polynomial, it must be in this form before we can differentiate. Now, Joy, you now agree. What are we doing now? In order to help us, maybe as I pick one question, I'll first of all state the law of indices I want to apply, or any law you have learned before that is applicable. I'll first state it before we now differentiate. Now that Joy understood that, how we obtain that, let me now ask this question. 1/x. Joy, are you still there?
Sir? Yes, sir.
How can we write this now?
Equals to
X
minus 1.
X raised to power minus
1.
X raised to power minus 1. Thank you. Now, having said that, I now want to differentiate. I want to differentiate. Joy, what is the coefficient?
Invisible 1.
Invisible 1, thank you. 1 times, what's our power?
Minus 1.
Minus 1, thank you. X, what are we going to do here from the formula? Check the formula.
The power is minus 1, so it's going to be minus 1 minus 1.
Minus 1 minus 1. 1 times minus 1.
Minus
minus 1, then x raised to power minus 2. That's what we did in the alphabet B. That's what happened in alphabet B. Do you get it now?
Yes, sir.
So any question? Now for alphabet C. Joy, you are the one that take us back, but no problem. I will take my time. Can I above this?
Thank you.
You
Yes,
have
sir.
listened it before.
Yes, sir.
Okay. I'm sorry, I assume that everybody still understands indices, but henceforth I'll be stating the law before I apply. In fact, I will start from here. I'll rub off this now. In C, you have y equals square root of x. So what I'm going to do is say that by law of indices, the law says that if I have square root of a, I should change it to a raised to power 1 over 2. Joy, are we together?
Yes, sir.
Now, if that is the case, this now implies that y will equal to what?
X raised to power minus 2.
Raised to power what?
1 all over 2.
1 over 2. That's all. Now we have written our question in this form. So what do we do from here? I'm coming those that raise hand. So
Oh,
dy
sir.
dx, what will it give us? Joy?
Sir.
Yes, what would this one be?
Don't know again.
You know, what's our coefficient?
Coefficient is X.
What's the coefficient here?
It's invisible one, sir.
1 times, what's our power?
1 all over 2.
1 over 2. Then x half. Then what happened here?
Minus
Minus what?
1 all over 2.
1 over 2 minus what?
1.
Minus 1. Thank you. 1 times half.
Anything times 1 is that 1 times 1 is 1 times I is half.
Half. Thank you. What is half minus 1? I have 1 over 2 minus 1. What I'm going to do? I can write it as 1 over 2 minus 1 over 1. Do you agree?
Yes, sir.
What is the LCM? What's the LCM? Joy?
Sir?
What's the
1.
LCM between 2 and 1?
1.
Are you sure? Lowest common multiple. That should be 2. 2 divided by 2.
1.
1 times 1.
1.
2 divided by 1. How many times will 1 goes in 2?
1.
No. Look at it very well. It should be 2. 1 in 2 is 2. 2 times 1.
2.
1 minus 2.
1 minus 2.
Yes.
Minus.
Thank you. Minus 1. Thank you. Minus 1 divided by 2. So the power now is minus 1 divided by 2. That's how we obtain that.
Okay. Thank you, sir.
You are welcome. You are welcome. We have not done anything strange today. What we are trying to do is to now look at different way through which the question can be asked.
Thank you, sir.
You're welcome.
What do you want to buy?
I'm just trying to look at. Sir, is it compulsory we add the law of indices? If you know the law directly, you don't have to add it. Just apply. But I am trying to add the law now because of series of questions I'm receiving. And that is pointing to the fact that some of us have forgotten the law of indices. The reason why I am doing all this, basically for revision's sake, so that when you are on your own and you pick your notes, you should know that from here, he has applied law of indices at this stage before he differentiates. So you don't have to add the law. In the exam, if the exam is theory, for instance, you don't have to write this. You just go from here to here. We know that you have applied the law of indices. So thank you so much. Oluwasegun Fasin. Kindly unmute yourself, please.
Good evening, sir.
Good evening.
Yeah, Dr. Gani. Sorry, I'm just joining the class for the first time, but with the little I can achieve, I achieve it and I enjoy it. That question number 3, D rather.
Okay.
You see, dy dx is equals to 2/3 times 1 into brackets x 2/3 minus 1. Now,
yes.
Sir, how do you reverse to that one? That minus 1, that's what's giving me concern, sir.
Okay. That means that you have missed one of our classes.
Of
The
course,
rule
I've
we are
missed it.
using
I missed
is
it.
this. Dy dx equals power times coefficient. Permit me to work on this. X raised to power minus 1. Let me write it in minus 1. So our power is 2/3. Coefficient was 1. So 2/3 times 1 is 2/3.
By 3.
The power is 2/3. Then the formula says that we should subtract what?
1.
So that's how we obtain our 1.
Thank you so much, sir.
You're welcome. Adebayo Adepeju. Okay, no problem. Olofingbuaro Peter, kindly unmute yourself.
Hello, sir.
Hello,
Good evening.
you. Yeah.
Yes, I'm so sorry for taking you back. The question D.
Okay.
So, when you are about to start, I lost my network, so I just reconnect now.
Okay.
I don't really understand the.
No problem. Like I said, I'll rub off this. By law of indices, nth root of A is A raised to power 1/n. So this now implies that our Y equals, if you compare this and this, our A now is X raised to power 2. And our N is 3. That becomes 1/3. So I have it now as Y equals X raised to power 2 times 1 will give us 2, then over 3. So this is what we are going to differentiate now.
Okay.
Let me write it properly. Y equals X 2/3. That's what we want to differentiate. We now go by our law. The law says I should multiply my power by coefficient. Our power is 2/3 and coefficient is 1. X, then 2/3 minus 1. 2/3 minus 1. That's what we have. So 2/3 times 1 will give us 2/3 x raised to power 9. We have 2/3 minus 1. It can be written as 2/3 minus 1/1. The LCM of 3 and 1 is 3. 3 divided by 3 gives 1. 1 times 2, 2. Minus 3 divided by 1 gives 3. 3 times 1 is 3. 2 minus 3 gives minus 1, then over 3. So that means that my power here is minus 1/3. Final answer.
Okay. Thank you so much, sir.
You are welcome. Finally, E. Okay, let me leave E as a exercise. E assignment. I'll mark it in the next class. Let's now look at techniques. Techniques of differentiation. Let me wait a bit because I may want to rub off that side. So let me just hold on. Okay. Oh, shit. Nneka, kindly unmute yourself.
Yes, sir.
Yes.
Yes, sir. Good evening, sir.
Good
The
evening.
part where you said 2 over 3 minus 1 equals 2 over 3 minus 1 over 1. Sir, you did you used the 3, the denominator, as the LCM. You did LCM, right? Yeah. You
Yes.
cross multiplied. Okay.
No, I didn't cross multiply. For us to get the LCM, take for instance, suppose I have 1 over 2 minus 1 over 6. I will ask 2 and 6. Will 2 divide 6 or 6 divide 2?
No, 6.
So
No, 2 will
divide
divide 6.
2 divide 6. So that means that 6
Yes.
is LCM. But let's look at it this way.
Okay, okay.
3. Will 2 divide 3?
No, sir.
Will 3 divide 2?
No.
I will now look for a common number that 2 and 3 will divide. To get that common
Okay, sir.
number, I multiply 2 times 3.
6.
So 6 becomes the LCM.
All right, sir.
So that's what I did.
All right, sir. Thank you, sir.
You're welcome. Now we now go to techniques of differentiation. The first technique, we did that in our last class, only that I didn't call it that name. So now I will now call it the name. Techniques. Techniques of differentiation. Some textbooks call it rules. Some textbooks call these rules. Some textbooks call it laws. So whichever case, or whichever the case may be, we are all saying the same thing. Law, rules, technique, we are saying the same thing. So we want to look at about 4 techniques: sum rule, function of function, product, and quotient. So I will start with sum. We have done sum already, so I will also start with sum. Banding, Kevin, kindly unmute yourself, please.
Yes, sir. You have not finished answering the questions. There's still one more question.
Yes,
E.
I take it as assignment. Assignment, sir.
Oh, okay, okay.
Yes.
Okay.
Thank you. So the first rule we want to look at is sum rule. Sum rule. Sum rule. So let's look at that law. The law says if U and V are functions of X, then the dx of U plus V is du plus or minus, let me put that way, du dx plus or minus dv dx. Do not disturb yourself with the notation. We have done it, you know it. So, but it is necessary. I should zoom in the camera. It will not cover the whole board. I can only increase the font of my handwriting. Let me increase the font. If U and V are functions of X, then Elijah, is it okay like this? Elijah, kindly respond, please. Okay. Then d dx of u plus or minus v equals the u dx plus the v dx. That is the sum. Let me now write this sum in different notation. As I said, we are going to make use of different notation. So can it be written in another form? The answer is yes. Some textbooks or some authors put it as y equals u of x plus v of x, or plus or minus the y dx equals the u dx plus or minus the v the x. We have written the same thing. Nothing changed. Nothing changes, rather. Some have written it as y equals f of x plus g of x. And they put it as the y dx equals f prime of x plus g prime of x. So these are the various ways through which this has been written. Oluwasegun Fasi, kindly unmute yourself.
Sorry, sir, my network went off. That assignment, that question was right. Can you? Yeah. Can you help me write it, please? Or maybe after the class.
No worry,
Okay.
don't worry. 2 divided by x raised to power 4. That's
All
the
right.
question.
Thank you.
You're
Okay.
welcome.
Thank you, sir.
So this is what we have. How do we apply this? It is not compulsory it should be 2 functions. It can be as many functions as possible. In fact, we started with this in today's class. Let me take the first question we did in today's class, then we now take it off from there. Let me rub up this. Question 1, example. Question 1. If f of x equals ax raised to power 4 plus bx raised to power 3 plus cx squared plus dx plus k. This is where we started. That's why I said, you know it, we just need to remind ourselves and tell us the rule that we have applied. So let me rub up this. Comma, what is f prime of x? Question mark. What is f prime of x? Solution. F prime of x, which can as well be written as df dx. So you don't have to write the 2. You can just 1, but I prefer this one here. So it says that differentiate this one separately, differentiate this one separate, cs squared should be differentiated separately, dx should be differentiated separately, and k be differentiated separately. Then the sign in between is addition. Add all of them together. That's what this law is talking about. Take them one by one, term by term. Each term, differentiate each term separately, then perform the required operation. And that's what we're trying to do. So what do we do now? What is the answer to, how do we differentiate ax raised to power 4? Yes, ax raised to power 4. We have done it today in the class. Ax raised to power 4, please. Yes, thank you, Gideon. 4ax raised to power 3. 4ax raised to power 3. I take that one. Plus, that is the plus you have here. Plus. Bx cube, what is the answer? Bx cube, what is the answer? Bs raised to power 3, the answer. 3bx squared. Thank you. What is the answer to the next one? The answer to the next one. That is 2cx. Thank you. What's the answer to the next one? The next one. Oh, Akinyimika Dan Michael. Kindly raise your hand. Michael Mata, raise your hand. Akinyimika and Mata. Both of you raise your hand. Akinyimika, kindly unmute yourself. You said that the answer to the next one is dx. How do you obtain your dx?
I see x does not have the power of x equals to 1.
Yes.
So it will become 1 minus 1, that's 0. So the answer is dx.
0.
Dx raised to power 0.
What is x raised to power 0?
X raised to power 0 is, that's 1.
So what's now your final answer?
Dx. Dx raised to power 1.
No couple. You say that you have dx raised to power 0, isn't it?
Yes.
What is x raised to power 0?
That's 1. X raised to power 1.
You can say that it is 1. Is that not?
Yes, sir.
So d times 1.
That's d.
That's d.
Yes.
That's d.
But I feel, since you said dx, I was feeling dx times 1, that's dx.
No.
That was what I thought.
Hello?
That's what I was thinking, dx times 1, that's dx.
No. You just follow the basic rule, you will get it. Don't think otherwise. You have gotten it to dx raised to power 0. Agree.
Yes, sir.
What is
yes,
x
sir.
raised to power 0? You said 1.
1. Yes,
so
sir.
1 times d.
That's d.
That is d.
Oh, I understand now.
So thank you.
Yeah, no problem, sir.
Yeah. Michael Mata, kindly unmute yourself.
I corrected myself already.
You have corrected yourself. Okay. No problem. I didn't see that. That's I only work with what I see. So I can move on. So plus d. So that solved the problem. That's all. Because derivative of k, what's derivative of k? What is derivative of k? Is 0 because it's a constant. Now, having done that, number 2, obtain the derivative of y equals, let me take some questions. Y equals, okay, 7x cubed plus 15x squared minus 9x plus 17. Everybody attempt this. And I will call some names down. You answer the question one after the other. Let me start with Aminat Ayomide. Kindly unmute yourself. Aminat Ayomide, kindly unmute yourself. Aminat Ayomide. Aminat Ayomide is not in the class. Okay. Let me go to Awe Shegun or Awe. Awe Shegun. Awe Shegun, kindly unmute yourself, please. Awe Shegun or Awe Shegun, either of the two. Shegun also is not in the class. Babalola David, kindly unmute yourself. Babalola David.
Yes, sir.
Is that Babalola David?
Yes, sir.
Okay, thank you. So, what is your result here?
Okay, sir. That is 21x.
No, something was written before that.
Okay, y prime.
Y prime. If you don't want to write y prime, then what do you write?
Dy minus dx.
Dy minus dx or dy over dx.
Yes, sir.
Okay, yes. You said 21
equals to 21x power 2.
power what?
2
Power 2
plus 30x power 1.
30x. Just that's all. Let me call another
That
person to take it off from there. Thank you, David. I really appreciate. Let me quickly go. Temilola Lawal, kindly unmute yourself. Temilola Lawal.
Yes, sir.
Okay. What's the answer to the next one?
The answer to the next one will be -9, sir.
-9.
Yes,
Is
sir.
that all?
Plus 0, sir.
Plus 0.
Because, yes, sir.
Thank you. Plus 0. So therefore, the y dx is 21x squared plus 30x minus 9. So we know it. So this is the sum rule. And quickly note this. Your exam, sometimes I may not ask you to differentiate. I can just write this question. F of x equals to this. Which of the following rules or which of the following techniques is applicable? I will now write sum rule, quotient rule, chain rule, product rule. You must know that what I've written is sum rule. So you are not just learning how to differentiate alone, you must also know the name given to each of the techniques. Esther. Kindly unmute yourself, Esther. Esther? Kindly unmute yourself, Esther. Yes.
Good evening, sir.
Good evening.
Yes, sir. Sir, please, I want to ask. You know, you said sum rule, and sum rule is addition.
Yes.
But the answer here I'm seeing minus. So
Yes.
so can minus be there if it's also sum rule?
Yes, minus can be there.
Okay, sir.
Yes.
Thank you.
You're welcome. Let's take one more question, then we round up the class so that I'm not bombarding with too many techniques. So next class, we'll look at another technique. I will tell you the technique, you read it ahead of the class. 3, suppose I give you y equals, if y equals 4x squared plus 3x minus 1 over x plus square root of x. Find the y dx. Solution. What is our dy dx? Ali, raise your hand. That's Ali Daniel. Kindly raise your hand. So it is now your turn. Ali Daniel. I hope Ali has not run away from the class. Ali Daniel. Ali is not in the class. Okay. Let me quickly look for define EKG. Kindly unmute yourself. Define EKG. Define EKG. Define EKG. Okay. Not online. Okay, no problem. Almighty God will forgive all of them. I have Fola Shade. Only Fola Shade here. Fola Shade, kindly unmute yourself, please. Fola Shade, kindly unmute yourself.
Hello, sir.
Hello. Thank you.
Good evening, sir.
Good evening. How are you?
Fine, sir.
What is the answer to the first one?
Okay, it should be, that should be 8x.
8x. Correct. Correct. Don't worry. You have answered the first one. Let me call another person. I'll call another person. Those that are raising hand that have answered the question before, I will not call you. So, except you want to ask me a question. If you prepare to answer that, put down your hand. I will not call you. All those that are here, they have answered question. They've answered my question. So, I am not looking. Yeah, somebody asked question here. Sir, why did 9 turns to 9 and 17 turn to 0? Who asked this question? David Favor. David Favor, can you kindly raise your hand, please? David Favor, please raise your hand so that I can answer the question. David Favor. Yeah, thank you. Kindly unmute yourself, David. David, kindly unmute yourself. Good evening.
Amici, sir.
Yeah. The question was 7x cubed plus 15x squared minus 9x plus 17. Do you understand how we obtain 21x squared?
Yes, sir.
How?
7 times 3.
Okay. What is now the power of x here?
1.
1. 1 times 9.
9.
9. X 1 minus 1.
0.
Is 0. X raised to 0. What will it give us?
Nothing.
Law of indices.
0, sir.
Is 0 or 1?
I'm not too sure, sir.
Okay, law of indices. A number raised by 0 is 1, except if that number is 0. If the number is not 0, any number raised by 0 is 1. Take note of that. So
Thank you, sir.
9 times 1 now will give us what?
9.
9. In our previous class, I made it realize that if you differentiate a constant, the answer is 0. Derivative of any constant. Derivative of any constant. Any constant is 0. So 17 is a constant here. What is differentiation of 17? What's differentiation of 17? Favor.
Sir, come again, sir. I did not get you.
Can you read this?
Yes.
Read it.
Derivative of any constant is 0.
17 is a constant. What is the derivative?
0.
0. So that's how this becomes 0.
Okay.
Did you get it now?
Okay, sir. Okay, is it that if any figure has no power, so
Has no
automatically
x attached, has no variable attached, it becomes 0.
Okay, sir.
Yeah.
Thank you very much, sir.
You're welcome. You're welcome. Yes, some people have answered this question completely. So let me also put 3. Then plus, someone has answered it, plus 1/2, 1/x², and a plus 1/2 x minus half. Please raise questions if you don't understand. Akinyemika Michael. Yes. Akinyemika, kindly unmute yourself.
How did you get plus? But the question is minus.
Thank you so much for that question. Now hold on. 1/x. Is there any other way we can write it?
That's x.
X raised to the power
minus 1.
Thank you. So x raised to the power minus 1. Differentiate this.
That's x raised to the power minus 1 plus 1.
Plus 1?
Yes.
Are you sure?
Minus 1.
So we are going to have minus x raised to the power minus 1 minus 1.
Yes.
Which is minus x raised to the power minus 2.
Yes.
Which gives minus 1 over what?
2. Okay,
now.
Okay.
Oh, you see it? Have you seen it?
Sir. Yes, sir.
Have you seen it?
Yes, sir.
And what did you see?
That minus x minus 2, when you break it down, to be 1, that minus is not, that x minus x2, that will be 1 minus x raised to the power 2.
Yes, then there's a negative here already.
Yes, that's minus.
This negative will now multiply what we have here, and it turn is positive.
Okay, minus times minus is plus.
Yes.
Okay, thank you, sir.
OT patients, kindly unmute yourself.
Good evening, sir.
Good evening, how are you?
Fine, sir. So my question is, how do you get 1 over after the plus 3?
How do I get 1 over x squared? I just explained it now, but let me re-explain.
Okay, sir.
Let me re-explain. Let's start this way. That I can write this as 4x squared plus 3x minus x raised to the power minus 1 plus x raised to the power half. Do you agree?
Yes, sir.
You agree? You have no problem with derivative of this 8x. Neither do you have problem with here, which is 3. Let's now take this.
Yes.
How do we differentiate this? Leave the negative here, just leave. The negative is still there. Let me put it here, plus, minus. Derivative of this one becomes, I use the power to multiply 1 here. It is minus x minus 1 minus 1. Minus 1 minus 1 will give us minus 2. There is a law of indices that says that
minus 2.
a raised to power minus n is 1 over a raised to power n. Using this law of indices, how can you write this?
Sir, please, I didn't get the question. The network, sir.
Okay, you didn't get the question. I said according to the law of indices, a raised to power minus n is 1 over a raised to power n. How can we write x raised to power minus 2 using this law? How will you write it? Patience, are you still there? Patience? Sure. Network. Okay. Patience, maybe after the class, you can communicate with me. There is no problem. Chisoba, kindly unmute yourself, please. I will round up the class now.
Good evening, sir.
Good evening.
I thought it's going to be 3x. Why is it only 3?
You thought this would be 3x?
Yes.
Okay, let's look at it together. Joy, I always love your question because they are questions that you know. Joy, let's go.
Sir?
What's the coefficient here?
Sir?
What is the coefficient? Coefficient.
X.
The coefficient of x. The number before x.
3.
3 times what is the power of x?
Minus 1, invisible 1.
Invisible 1 times 1. Thank you. X raised to power invisible 1 minus what?
1.
Minus 1. Thank you. 1 minus 1.
Nothing.
And there's nothing like that.
0.
Is 0. X raised to power 0. 3 times 1.
3.
3. What is the value of x raised to power 0?
No. 3.
X raised to power 0. Chisoba. X raised to power 0. X raised to power 0 is what?
1.
It's 1. So what's now 3 times 1?
Okay, it's still 3.
So that's how this one.
Thank you.
Yeah, you're laughing also. That's how we get 3. So this is where I will draw the curtain of today's class. I wish you all the best of luck. Just take your time to revise what you have done today. Take any textbook on calculus. Just look for questions on this. Any question that is tougher, that is combining so many law, don't bother yourself with those questions. Just go straight to what we have done so far and try as many questions as possible. So till next time we're going to meet, I wish you all best of luck now and beyond. Thank you and God bless. And good night.